All right. So this is the question. An object is thrown horizontally from the top of a 45-meter building, and the initial velocity of the object is 30 meters per second. Right. So we all know when we throw an object like that, it'll take it'll eventually take a path like this, a parabolic path. Right. So there are a lot of questions they have asked. Let's see. So the time initially will be 0 in the stopwatch, and then when it hits the ground, let's take that time as t. All right. And we just studied the horizontal component of velocity doesn't change. So even when it hits the ground, it will be 30 meters per second. All right. But when it hits the ground, it's going to have a vertical velocity component. So we don't know what that is. Therefore, I'll take it as v, the vertical velocity component. Okay. So that's another unknown we have to deal with. Yeah. Right. So talking about this question now. Before I start the question, I'm going to write some information which are very important for the upcoming questions too. Now, this object is moving horizontally and vertical, both. Because see, it has moved horizontally and it has moved vertically too. So you have to consider two things. One is this now. I'll mark some distances. It's moving horizontally. This distance, this is the horizontal distance it has covered. Let's take it as r. We normally call it range. So I'll take it as r, or whatever the data you can choose whatever the data you want. Right. Now I'll get back to the most important things. Now for the object, it will have a displacement. Now considering displacement, I said it has vertical component and horizontal component. So displacement in the vertical direction will be downwards 45 meters. Okay. From this level, it has gone down 45 meters. And displacement in the horizontal direction, it was here initially. Now it has gone this much distance that we don't know. That is r. All right. So for displacement, there are two components: vertically 45 meters downwards and horizontally r towards right. And then talking about initial velocity. Initial velocity, right? So you can clearly see initial velocity in the horizontal direction is 30 meters per second. Initial velocity in the vertical direction, how much is that? It's going to be 0. Why? It is thrown horizontal. Therefore, it won't have the vertical component. And acceleration, right? Talking about acceleration, vertically, acceleration is going to be 10 ms minus 2. And people, horizontally, what is going to be the acceleration again? What is the acceleration horizontal? Horizontal acceleration? Once again, it is going to be 0. Why is that? There is no air resistance. So there's no force in the horizontal direction. So horizontally, acceleration will be 0. All right. So these three things, or actually 6 things, you have to know them precisely. You have to be absolutely sure about this. Then only you can do the questions correctly. Okay, right. Now let me explain the questions one by one. And if you follow the steps, then you can get the answer right. How long will it take for the object to hit the ground? Or how long will it take for the object to hit the ground? Right. So talking about that question, number 1. Yeah, let's start here. Number 1. What does it say? Now, vertical displacement, we don't know. We know, sorry. Downwards displacement is 45 meters. And vertical acceleration, we know 10 ms minus 2. And vertical initial velocity also we know, that is 0. Careful, vertical direction, it's 0. So they ask me for the time. We know displacement, initial velocity and acceleration in the vertical direction. So 3 things are known, only time is unknown. Hence, you can apply S equal ut plus half at square downwards. S equal ut plus half at square downwards. All right. So what is the downward displacement? 45. I'm applying the equation downwards. So whatever is in downwards should be taken as plus. Initial velocity is 0 plus half into 10 into t squared. So 45 is going to be equal to 5t squared. T square is going to be equal to 9. Therefore, t is equal to 3 seconds. It will take 3 seconds for the object to hit the ground. All right, fine. Second question, what does it say? What will be the horizontal displacement of the object when it hits the ground? They're asking for the value of r. All right, so that's not hard at all. I'll write the answer here because it's not going to take a lot of space. Now we have applied the equation s equal ut plus half at squared downwards. Now apply the same thing horizontal. All right, fine. Now horizontal displacement, well, we don't know that. We don't know that yet. So I'll take it as r. We have marked now, see, horizontal is r equal to now horizontal u, that is 30, into time we have found 3 seconds, 3 plus, here you have to be careful, half into, for acceleration, you should not put 0. If you put 0, it's wrong. Sorry, you should not put 10. You should put 0 into 3 square. No need to substitute this actually, but for your clarity, I just substituted it. Why am I not putting 10 for A? Because horizontal acceleration is 0, but vertical acceleration is only 10. So here you have substituted the horizontal one. Therefore, 30 into 3 is 90 meters. This part is 0. You don't have to write this. You can skip that. 90 meters. Okay, go. That will be the answer for the second question. Now, third question. What will be the magnitude and direction of velocity of object when it hits the ground? Right. Now, when the object hits the ground, what's going to happen? 1, 3. When object hits the ground. When object hits the ground, people, as you can see in the diagram, it will have a horizontal velocity component of 30 meters per second, and it's going to have a vertical velocity component v. Now the problem is we have no idea about that v. We have to find that. Okay, how will you find that v? Now, if I know that v, I have the final answer. So how am I going to find that? For the object, why don't we apply this equation? Downwards v equal u plus at for the object. Okay, so downward final velocity of the object is v. We don't know that. What is the downward initial velocity of the object? What should I substitute for downwards initial velocity of the object? Can I get some answers quickly, please? How much is that? Right, good. It's going to be 0 because the initial velocity component of the object, it will be, we know it will be 0, right? And for acceleration, what should I substitute, guys? For acceleration, what should I substitute? Plus for A, what should I substitute?
Number
10. All right, it should be 10 and time is 3. So finally, V is equal to 30 downwards. Okay. Right. So the final vertical component is 30 meters per second. So guys, we all know what we have to do after that. So there is a horizontal velocity component of 30 meters per second. There is a vertical velocity component of 30 meters per second. So we have to find the resultant velocity, V. So what is the value of V? Can you all tell me quickly? We have learned it under vectors. When there are two vectors which are equal in magnitude and perpendicular to each other. So what is the value of V? Yes, one correct answer. That is 30 root 2 meters per second. Now for root 2, if you want, you can substitute 1.41 and get another answer. I'm happy with this. Now how do you find V? How do you find V? Square root of 30 squared plus 30 squared. So that is V equals 2 into 30 square, right? 30 square goes out. So 30 root 2 meters per second. You can find the answer anyway. It's not a very hard thing to do, right? And when you say a vector, they're asking two things, magnitude and direction. So the resultant vector is in this direction. What is this angle? Tell me quickly. What is going to be this angle? Horizontal component is 30. Vertical component is also 30. So what will be the angle the resultant vector is going to create with horizontal? Yes, 45 degrees. Good. It will be 45 degrees. So we are done with that question. Okay, right. For the last question, it says we have to plot the VT graph. We have to plot the VT graph for the components separately. So if you take the components of Roman 4, first one is horizontal velocity. So I'll take velocity horizontal direction, horizontal. And when you say velocity, we have to put the unit meters per second and time in seconds. So how will the graph for the velocity, sorry, horizontal component of velocity come? How is it going to be the graph? Can I get some answers, please? How is it going to be? Horizontal component. Now, as you can see, the horizontal component, it remains at 30. Every second, it will be 30. So you will get a graph parallel to x-axis. Yes, correct. A straight line parallel to x-axis like this. So if you know the numbers, it's always better to substitute those numbers in the graph. So it will give a good completion. 30 here, 3 seconds. All right, 30 here and 3 seconds. And the vertical velocity, what kind of graph can we expect people? Vertical velocity can be vertical in meters per second. Time is in seconds. Okay. What do you think? What kind of graph can I expect for the vertical velocity component? Initially, you can say the vertical component is 0. After 3 seconds, the vertical component is 30 meters per second. Therefore, the graph is going to be this. All right. After 3 seconds, velocity component is 30. Very straightforward. It's just substituting the numbers you got. And well, the graph should start at 0. So it's actually y equal mx. Y equal mx. So this is the graph for the vertical velocity component. 0, 10, 20, 30. So it will increase. For the horizontal one, 30, 30, 30, 30. So it will remain as 30.